Student procedure. Once the equipment is set up, students will complete a calculation to find the distance between the slits of the diffraction grating. They will measure L, which is the distance between the diffraction grating and the light source. So that's this distance over here. This distance should remain fixed for the entire lab. Students, one at a time, will look through the diffraction grating and record the distance between the light source and the violet, green, and red light as X in the data table. This works best with one student looking through the diffraction grating and a second with a pencil point moving along the meter stick. The student looking tells the one with the pencil to stop, and the one with the pencil reads the distance. It can be hard to focus on both the color and the numbers. So we have one student looking, and the student sees the violet light somewhere in this location. The other student has a pencil, and he's pointing down to where the student looking through the grating thinks he sees the violet, and whenever that pencil point aligns, that's the distance you measure off of the meter stick. So that would be where violet is, green is over here, and red is here. So it's a two-person operation. Students will repeat for the second spectrum, where M is equal to 2. Some adjustment may be necessary in the equipment to make sure the entire second spectrum is visible. They will then calculate wavelength, frequency, and perform an error analysis. This data table should be used for your class, and it's used to calculate the wavelength of light for the first maxima, M is equal to 1. We have the distance from the source to the grating, and we're going to keep that fixed. We do that with the meter stick. And then through the combination of pencil and eyesight, we find the distance from the source to the first order maximum. This should be calculated ahead of time, and that will stay fixed. Then we can calculate wavelength and frequency. Please click here to view the lab procedure. Tips for performing the experiment. Make sure the light source works properly. Use a track or meter stick to make sure that the light source and diffraction grating are perfectly aligned. Keep spare diffraction gratings. A cloudy or scratched diffraction grating can cause errors. Having all the equipment fixed securely in place is important. If it should move during the lab, students have to start all over and measure L for this new position.